Well, so this is KiCad 5.0.2. It was just released just a couple weeks ago, probably even less because it takes a little bit longer to come out, I guess, for the Linux platform. But I was about to do this tutorial and I realized I needed to update this. And boy, at least as far as colors are concerned and icons, a lot of things have seemingly changed. I'm hoping that it's not too far off from the typical that I can't continue to do the tutorial. So, having said that, here we are, 5.0.2. Look at this. KiCad, 1992, they started doing this. So this has been going around for a long time. Open source set of open source applications, as you can see. So they, like a lot of things in the open source world, it's not just one big program written by some people. It's some people, and then you have a bunch of support programs written by other people that they just kind of fold into it. So it makes things work a little bit easier, I guess. So anyways, without further ado, we'll go ahead and take a look at this. So the first thing we're going to do is look at the interface as you would with any kind of, software, Fusion, 360, CATIA, anything. The first thing you start with is what the hell is going on here? So we're not going to really do too much with this right off the bat. The thing you want to be kind of, probably most concerned with is how do you create a new project? So here's that button right there, of course. Now, what happens in KiCad when you create a new project, you're going to create a holder for this project, right? This holder is a folder. So, that's kind of normal, except what's going to happen here is this is kind of like your first screen here is kind of like looking at a folder in your operating system anyways, and any files that are in that actual folder will list here on this side as well. Okay, it'll be kind of more clear in a minute here. And when you start a new project, it automatically breaks it into two pieces. It makes it two pieces. One is the schematic and one is your PCB layout as well. Okay, so keep that in mind. This first window here, container for the project. That's kind of what you want to think about. The project could be many pieces, and it will be many pieces. It's going to start out with your schematic and your PCB. Then you're going to get net lists in here. You might have some other libraries or library caches in here. If there's any pictures you feel like you want to put in, then they'll be in here as well. And then when you finally export this into Gerber files, the files that you're going to upload to the PCB board house, you're going to see all of those in here as well, and probably the zip file that you're going to make from all of those things. So a whole bunch of stuff is going to be in here. Remember, it is the project, a bunch of other things, a bunch of other pieces. Okay, so let's make a new project. So when you come up here, you're going to go create a new project, and it's going to ask you where you want to store this and what do you want to call it. So as you can see, I've already made a folder called KiCad Projects. So that's fine. Now what you're going to want to do is just give your project a name. And we're simply just going to call this Lab 01. And you can probably give it something more descriptive for the name of the project that you're doing. And then you hit save. So now what it's going to do is it's going to create this down here, your KiCad project file, so your .pro file. And then it's automatically going to create that sketch and the PCB file as well. So hit save, and then you get this right over here. Now, when you're looking at this window here, it looks as though the PRO file is the main directory, and these are children of that, and that's fine. That's probably a great way to look at it here. But physically, inside your computer, I guess if you want to call that physically, they're over here. And so in KiCad Projects, in Lab 01 folder, there's a PCB folder file, and there's a .pro file and a schematic file, all in that same file. So then if I were to make anything in here, or you make a new file in here, as you will, just in the course of doing things, a net list or what have you, anything in this actual folder will show up here. So for example, if I create a new document, test dot, now I have to call it txt here. Linux doesn't need it, but whatever, it doesn't show up if you don't do it. So test.txt, and boom, over here you see this. Now you're probably not going to do that unless it's something like, sometimes you want to bring a picture file in, and you might bring it here so you could use it inside your project. But typically all of the files in here are going to be created within KiCad as you go on. Incidentally, it's supposed to be pronounced KiCad, right? As far as anybody can tell, it's French originally, and it's supposed to be KiCad. I think I originally called it KiCad, and then I can blame it on Chris Gamble that I started calling it KiCad, and then I got stuck, and now I'm trying to retrain myself to call it KiCad again. So whatever, call it whatever you like, but if you hear me bounce around back and forth, that's why. So what I want to do now is I want to see if I can give you the quickest, simplest, high-level overview of the program as possible first. Maybe just even in this video, and then we'll move on later. Because what I've discovered with this, like so many other complex programs, is you might have 1 to 3 topics to 5 topics, I don't know, whatever, but each one of those seemingly simple items has got multiple threads to them, and then so on and so forth. And if you try to address each, even a portion of all that stuff as you hit each topic, it becomes really kind of difficult for a new person to grasp the entirety of the software. So I want to see if I can just zip through this without causing too much confusion, and make it kind of simple, and maybe even allow you to just kind of get started with something, albeit not perfectly correctly, just get in there and start mashing some buttons. Okay, so well, let's see, for just to make things simple, I'm going to get rid of that test text file. Okay, so that's out of here. So let's say I want to make a PCB. That's why we're here, right? So I'm going to typically make a schematic first. Almost always you're going to make a schematic first, and then you're going to take your schematic and you're going to turn it into a PCB. There is actually reasons why I have made PCBs without a schematic. One example is a solder practice board that I made, and it didn't have to have any components on it whatsoever. It just needed to have a bunch of pads on there of different shapes and sizes that people could practice soldering on. So that's, off the top of my head, the only time I can think of that I jumped in to make just a PCB. So anyways, you go here and you find your schematic file and you double click it, and you get a new window. So this is kind of the beginning of understanding that this is multiple different pieces of softwares, I guess you'd say, right? So this is your schematic editor. When you're done with this, then you'll open up your PCB editor, and this is new here. Can give you a smoother, faster experience if you turn on acceleration. Well, yeah, of course. If we got it, let's turn it on. So then this is your PCB layout editor. So this is when you go to do the layout, this is the window that you're going to see. But as you can see, I shrunk it down here so you can see the main project window is still there in the background. So typically you end up opening up kind of all three of these. You always have the main project window open in the background, and then you'll have the PCB and the schematic open up at the same time, and you kind of maybe bounce back and forth between the two. If, in a perfect world, you'd make the schematic, everything would be beauty, and then you would save everything as a netlist. You'd open it up in your PCB editor, and then you'd route your traces and you'd be done. Reality is you usually forget something, you want to change something, there's a little mistake, or maybe the rules checker says that, oops, you forgot an open trace or something, and you have to go back and fix it. So you end up with both windows open and you bounce back and forth. Okay, so I'll close that down, and we'll go back to the schematic window. Now what we want to do first is, hopefully you've kind of thought out what you want. You say, okay, well, I want to make a project that blinks a light. I want to make a project that provides power or switching to a motor. You have your task kind of in mind that you want to do, and now we want to start placing these components out. You don't have to draw this out somewhere else first and bring it in here. I mean, this is fine as a sketch pad. It works great for just kind of getting your ideas out. And I'd even go so far as to say, with the cost of PCBs nowadays, the whole entire process can be just a sketch pad. For the sake of $25, if that's not going to hurt you too bad, you can throw your ideas together and ship them out to the board house, get them made, and then come back and test it out. And if it's wrong, then you do it again. So the first thing I imagine you're probably going to want to do is place a component out here in the field somewhere. So if you're looking around, you got all the typical icons for things. The stuff you're going to want to have to place and do is basically over here. Over here you can see is kind of your units and some other things. Then up here is what would I say? Should we call them No, not modifiers. Rule check, annotation, or association, libraries, and what have you. So if you're trying to place components and do something to the schematic, odds are that it's going to happen over here, and it's really going to be pretty much this guy right here and this guy right here. These are kind of the biggies. Adding some of this, doing some of that, some net names. Yes. So look over here. What we're going to do is we're going to place something here. We're going to put some type of schematic symbol on the board first. So you go there, you click, and it's going to pop up here and say, where is your symbol? Okay, so we have our couple files here. We have our .pro file, our PCB file, and our schematic file. Everything is all set up here. Now, I want to make a mention that just before I started speaking these words that I'm speaking right now, there was quite a snafu here with the upgrade from 4, I was back at 4, to 5.0.2, and it caused a lot of grief with libraries. And so rather than, divert this right now, I am going to put all of that, just cut it in right at the end of this video so that we'll have, we can stay on target with our real simple KiCad overview. And then at the end of it, you can see if you want to watch it, if you're having problems with an upgrade from 5.0, some of the stuff that I had to deal with to get that to work out. So PRO file again is our project file. PCB is going to be for PCB layout, which we're not going to get to until we finish our schematic. Our schematic is down here. If you double click on each one of these, they will open up their own editor, okay? And this is always here in the background somewhere, this main project envelope, if you will. And then, for example, if I double click on sketch, here is my sketch. I can close that. I can double click PCB, and then the PCB editor opens up. So we'll start with the schematic editor. You come over here, and one of the first things you're going to want to do is add a part in here of some shape or form, and this is all just logical symbols. This is your schematic editor. So we're putting things together in, in a logical sense. So rather than try to arrange them in the way that you're actually going to see it on the board. Some people might like to do that just for commonality between the two, but really it is not necessary whatsoever. So I just added in a battery. Okay. Now consider this. Think about this. You can add a battery in. This is kind of like for our own information. It is a battery, but on the PCB, this feature right here, are we going to solder a battery onto the PCB? We're not going to solder the leads, right onto the PCB. So this is ultimately going to be some holes. It's going to be holes maybe going to a connector that you plug the battery into or something like that, but it is not going to be the battery itself. So at the end of this, when we're ready to go to the PCB editor, we're going to associate this symbol with a footprint. Okay, and so sometimes I'm going to call these footprints too. I'm going to call KiCad and all that kind of crap back and forth again, right? Forgive me. This is technically right now we're calling this a symbol because it's a schematic symbol. And then later when we get to the PCB editor, they call the thing that looks the footprint, They call it a footprint that looks like the shape of the pads of the thing that you're going to solder onto the board. Okay. So then we're still here on this, so I can go ahead and add in another component. I want to add in a resistor, so there's your resistor. We'll put that in here. Now, if you want to rotate it, when you have it in your hand, we'll say this is in my hand, I'm holding it, you can hit R and you can rotate it around. Notice that the words always stay right side up for us, which is nice. So I'll put that in there. Now, if I wanted to move it again, I hit the M key. So I get over the top of it, I hit M, and now I can move it. And when you're moving it, then you can rotate it again. If I just wanted to rotate it, you can hover over it, and then you can hit rotate, and it will do that. Okay? If I want to copy it, because I want another one of them, I can hover over it. I can hit C, and then I get another one. C for copy. There's another one. Okay? And I'm scrolling in and out, zooming in and out. And so notice that the scroll follows your cursor. So that might be kind of awkward for some people if you're not used to this. Then let's say I want to add in an LED. So I pick another one here. And as you notice, I'm just going up to the top, typing LED in here, and having one pop out rather than search all of the categories, open them all up and try to find one there. Here is our classic LED symbol. So we'll grab this one. And I'm going to rotate. No, I'm going to leave it just like that. And then maybe I want to make a copy of that, so I'll move it over here. All right. Now realize that these symbols right here and the footprints in the footprint editor, they come from either you making them up, you downloading them from the web, or maybe you even have your library paths associated, connected to the GitHub repository. And so maybe you just click some stuff and you update these from time to time. So realize that if my symbols don't look the same as yours, or you can't even find my symbol, that doesn't mean anything. As long as it's a diode or it means diode to you, LED, all is fine. Okay? So this one right here, as I'm clicking on this after the 5.0.2 upgrade here, and new symbols, honestly, I don't really like the line going through it, but who cares? The last one I had it without the line, and it was hollow, white in the center there, and the one I had before that was solid black with a line on it. So, go figure that. So different changes. And in a separate video, we'll talk about library editing. You can make up all of your own, which if they're ones that you use a lot and you like them, or if you have you yourself as a company or you have a few people with you, it's a really great idea to make your own libraries, and you include certain types of information that is important to you and your people, right? It might not be good for everybody in the world, but it tells you things like, what model or something that this device goes on to. All right, so good enough. So we've got a battery, we've got some resistors, we've got some LEDs, and then we want to connect this into a circuit. So then the next thing you want to do is over here, you have your wires. So you come over to wires, you pick this, and it's simple enough. You just pick this and you click and you bring it over, okay? And you connect. Keep doing it. Now, I recommend that you zoom in when you do this. If you do it from out here, you can kind of sort of guess that you're there, but you can, if your grid is tiny enough, the dots that I'm snapping to, you see, you can change that. If your grid is tiny enough, you can miss it by just a very small amount, and then when you go to build a thing or test a thing or go to PCB editor, you'll end up having a problem. There is a rule checker for that. So I'll come over here and I'll do this. I'll connect from here to here. Now, let's see if I can make this happen here. If I go here and I just bring it down, I might not like it coming straight out of that resistor like there. I kind of just have an OCD about that. So I want it to come out a little bit, but then when you bring it back, you bring it out and then it comes back. You bring it out and it comes back. So if you want it to be out here, you can click and it won't stick there. I mean, it's not going to end the line right there, but it will stick it in that position, you see? And so I can get this thing to go how I want the things, how I want it. I feel like I like these things to come out here because if I want to write a net name, if I want to add any information, it keeps this thing free and clear and I'm not running into a line. I don't know. Maybe it's just it looks better to me. So then I come in here, click, click, keep going. Come around here. Could have moved the battery up. But then that's it. Okay? So there is my circuit done. So that's kind of first job. So we get this thing laid out, say that, you go, yep, That's what I want to do. This is my layout. I want to have 3 resistors in parallel for whatever reason. I had a bunch of cheap ones laying around here, and I needed to stack them all up. Seemed better than buying them, and some LEDs in series as well with the battery. Sounds good. So now you go, okay, good. I want to go make this into a PCB. So let's go to the next step. So you think, okay, go to the PCB editor. Couple more things first. So probably the first thing you could do, if you forgot what the next thing is to do, just go up here to the your bug checker, right? So this is your design rule checker, right? Electrical rule check. And if you hit run, it's going to tell you something. And in this case, when I hit run, it's going to tell me that I've got a whole bunch of the same named parts. You see? So it stops right away after BT, and it says annotation required. BT right there, not done. Okay, so you go over here, and this being a symbol, if I click on it, well, see how I'm carrying this pencil thing to add a thing? Hit escape, and it drops it, right? So now you're free to click on something if you want without having to bring up a new component. I could right click on this, and I can have some options here, right? So you could go to properties, you could go edit value, edit reference, edit footprint, edit library. We'll talk about more of these specifically in some other video. What we want to do maybe is just, well, let's see if we go edit value. So the value is your name battery. I don't necessarily want to change that unless I want to put in something like 3.7 battery, something like that, right? So then you go, okay, well, let's try that again. I go to properties. How about edit reference? And you get edit reference BT question mark. Yes, that's what I want to change, okay? And I could get here and I could change it, right? But what I want to show you is if you're careful, if you hover over the right thing, if I'm over battery here and I hit E for edit, it will bring up that value. If I hover right over BT and I hit E, hear that on the keyboard, for edit, it brings up that value. So we're going to say BT1. This is the thing that you might end up having on your circuit board for placement, because this is part 1, part 2, and part 3. So if, we're going to have 20 batteries on here, which we're not, but say we were going to, for whatever reason, we got BT1, BT2, BT3. Especially important with resistors, R1, R2, R3. You can list in what the ohm rating of each resistor is, for example, if you like. If you don't feel you have the room for that, you could just leave it tiny like let's see how that works. I could leave it tiny as R1, R2, and R3, and then you just have some kind of sheet that goes along with it that tells you what those are. That gets kind of messy because if you lose the sheet, you're kind of screwed. So, it's kind of nice if you can somehow get on here the ohm rating. So when you're putting the board together, the board, in some kind of a perfect world, you can assemble the board by having just the board. Okay? That's also a little bit kind of impossible in a way because, it says, diode 1, 2, and 3 or whatever it says, but, resistor, whatever, but it doesn't necessarily tell you maybe the size that you're supposed to order or the type. And you can't write a book down here. So anyways, we'll come through here and we could edit each one of these, and I could say R1, R2, and R3, and that would be fine. But if you want, there is a wizard to help you do this, of course. So if you come up here, see the pencil and the paper, we're annotating it. I guess that's what they're doing with that symbol right there. If you hit this, it'll pop up this window that says, do you want to do the entire schematic? Do you want to keep the existing annotations? Do you want to, I don't know why you do that. Sort the components by X position. Okay, sure. Anyways, but this one particularly, keep the existing annotations. If I want to reset all of them, then this BT1 might change, for example. So if I say annotate, we'll get this off to the side here. Annotate, boom. R1, R2, R3, D1, D2, D1. Oh, bummer. Okay, I wanted that to be D1, D2, you see? So for the most part, it kind of does it okay for you, but if you had kind of a flow that you wanted to go with this, and you wanted to name things in some sort of logical order, logical to you, logical to your people, then you don't get to do that, right? Or maybe you get to do part of it. Maybe you edit the ones that you wanted to do first, and then you run the wizard, but you say, keep existing annotations so it doesn't clear those out. Okay, so I'm going to change that to D1, and I'm going to change this one to E for edit to D2. Okay, that's it. Now, again, you can run the rule checker. Run it, and finished. Hey, that's nice. we just did this the other day and we're commenting that we had, when everything is working, there is no indication that good has happened. It just doesn't do anything. It's blank. And so you think, did it do anything? Click, 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 click. I guess it's okay, right? Thanks, guys. So now you have an indicator saying it's finished. And assuming there's nothing here, there's no errors. Let me show you what happens if we come into here, and I'll hit delete on my keyboard, and I'll take this line and I'll bring it right out to about here. Double click. At one click, it won't work. Double click, it stops it. So from a certain zoom level, it might possibly look like everything's connected. So you hit the DRC or the checker, and you hit run, and it will tell you something is not connected. And we've got two errors here, right? Because what they're saying is not the wire is not connected. We've got two pins not connected to another component. So if I close this, I'll show you a couple things here. If I click on this, it kind of focuses you on one or the other. And so then if you're just scroll zoom, you'll kind of go into it, sort of kind of whatever. It brings you kind of to it. If you hit close, the arrows remain, and then you could zoom in to the arrow and go, what? Oh, bummer, didn't get it connected. But what the heck's over here? This one's connected. This one's connected. Well, the wire is connected, but it, because of the other end here, is not connected to a component. So we got to fix that. So we'll just grab a wire here, and it's simple enough. You go from here to here, and connect it. Now that might bug you, but I've noticed that you see how I deleted that whole entire line right there? It doesn't leave a segment in there. So it is okay to just go ahead and add on to that and connect. It might have been okay anyways, but in other programs and other things, I don't like having like one wire that's actually comprised of multiple different segments. Okay, so we're good, we're fixed, except the arrows remain. Well, they're not active, so you have to come back here and you have to say delete the markers. You delete the markers, and then you run it again, and then it says finished, and we are all good to go. So now we close it, and now we go make a PCB? No, not quite yet. So now we have to associate these footprints here with a real life component, right? I just called them footprints again. These symbols need to be associated to a footprint, and the footprint is going to be the electrical pads and the shape of the actual product we're going to use. So this is where everything takes a hard turn around to the left, to the right. It's not good. So you are going to go assign PCB footprints to a schematic symbol. And so you go here, loads the footprints, and now what you're seeing in this window is BT1 is battery, and right here it says what footprint is that associated. D1, LED 1 is what footprint, so on and so on. None of these have any association to them. Association. So if I go to battery, well, again, remember, we don't want a battery. We just want a 2-pin connector. Diode, LED. So which one do we go here? So we scroll through here, and we got some diodes, but if you keep going, you'll find LEDs. So then you go, okay, well, is this going to be a through-hole LED, or is this going to be a surface mount LED? Well, I don't know. Well, let's see. For ease of use, maybe it's a simple lab, we'll go with a through-hole one. All right, so then which one do we pick? So we scroll through here, and we start to look for different ones, and you click on some of these. If you come over here, we can go footprint viewer, and we can look at this and go, well, that's weird. That's not the LED that I want. So you start looking around, and ultimately what I want everybody to do, for the most part, and except for some really super duper jelly bean stuff, and even that, I want us to make our own footprints. I want us to develop our own library. I feel like the more you get used to doing this, the easier, of course, it becomes, and the less willing you are to sacrifice any kind of board layout for something other than your own. Anything that somebody else has done is maybe, not quite right for the way you wanted it, and you're not satisfied with that. So you go, you know what? Piece of cake. I'll go in and throw a few pads out here, and I'll draw a square around it, and I'll call it mine. and label the pins the way I want them, which is a huge deal. And I'll call it my own. Okay. So, there's that. You can keep searching through here looking for one, and you go, okay, yeah, that's kind of it. Except this is more like an RGB one, so that's not the one we want. And until keep going through until you find the one that you're after. Okay, which would probably end up being something like this 5mm diode, LED. Sure. Go ahead and use this one, right? You could use that one. But now let's go to the next point here, why this is such a potential, chasm in the road of, getting to our next process here, which would be making our PCB. And this is actually why I love this, though, because there's so many things that you can do theoretically, in a class or something. You could say, well, you make a schematic and you bring it to the PCB, you pick some stuff right here, and there you go. There's your board. Cool, then you could make it, right? Except you absolutely positively can't make it. You could make it, but you can't solder it because it's all screwed up. Because if you pick default stuff and you just randomly guess here, you didn't make anything. The part that is the hardest about, I think, about all of this stuff is you've got to now pick out what diode you want, which resistor you want. If it's a through-hole resistor, whatever. That's cake, right? But you've got this, barrier rectifier or some, surface mount component that comes in different sizes and different shapes. The pads are different thicknesses. Which one are you going to go with? And what are the characteristics of it? What's the forward voltage drop? What is the the internal resistance? What is the gate voltage on the MOSFET? What's what? All the way down the road. What are the things you need to know for a real circuit to get this thing to operate? So what I'm getting at is we kind of got to stop this one right here. And we've got to move on to a DigiKey exercise or Mouser or, all the other component places out there, because we've got to go find the actual component that we want. And now we're getting into some electrical theory and, you're building your real circuit. I'm going to pick out some stuff now here. But then we're going to just to knock this out here, then we'll go off to DigiKey in a later exercise. Well, for the battery, I'm going to pick out, I just kind of scrolled through here a little bit. I'm going to pick out this 2-pin terminal block. It looks like this. This is, again, it's a perfect example why I would want to make my own, because do I need this block and box around here? Maybe. Maybe I'm going to use it. Maybe actually this is a pretty good idea. Maybe I'm going to use a terminal block for this, and I'm just going to wire the power into it. Do I need it to say terminal block on here and all these things? Well, let's go with it for now. Again, for the sake of getting this done and moving on to the PCB so we could do some traces, show the overview, and then start coming back in successive videos to pick off all of these little tangents that I'm mentioning along the way. So if I want to associate this to this, you just double click it. That's it right there. Now this battery is associated to that terminal block. Now for the LED, I should have done that while I was looking at it there. So let's say we'll go to LED through hole, and which one we're at? We're at one of these 5mm clear. Oh yeah, these are the sideways ones. Yeah, let's go with that one right there. So take that, we'll double click that. And we'll do another one. So, you see? So now we've got our 2 LEDs done. Now the resistors. Through hole or SMD. All right. Well, we'll go through hole again. And let's say we want a length. See, I'm looking here. This I should probably kind of do this from time to time, is show you kind of where my eyes go to. And honestly, I don't spend a lot of time in these ones because I pretty much go straight to the data sheet and make up my own. So this one here is going to be an axial one. So see the pad right here? Remember they still do it, but the old school way of making your resistor go straight up in the air and then the lead just bends over and comes down? That's what's happening right here. So this seems like a good one, and I thought I would show you what I was doing here. You see how my cursor jumps around from point to point to point? If you check it to millimeters over here, millimeters, inches, if you hover over anything here, see how, look down here. Look down here in this corner, and you'll see these values, x and y, right? dx, dy. Now if I come over here, let's say to this dot, look right here at the dx, dy section here. And if I hit the space bar, you see everything just went to 0. Now I can move this around, and it gives me a way I can measure things if I want to. So I can come back here, and I can get right into the center of this hole right there, which does happen to be at 0, 0, but just watch the dx, dy again. Hit 0, and then I move it out, and I move it to the center here, and it says that the distance here is 11.43 millimeters, okay? So I'm looking at this, and it says the length is 12.4 by 4.8, and so you're like, wait, that's not right. Well, if you keep looking here, we got the 11.4 right here from center to center, but I don't feel that that's super intuitive, and as you're looking through the thing, you might not recognize that. Anyways, this seems like it's probably good because your standard resistor is about 10 millimeters or so, and bend the leads nicely so they're not like bent right at the end of the damn thing. Maybe that's going to be good. So let's go with this one. Okay, so I just wanted to show you how to check size and scale on here, and we'll close that out, and we'll throw this in. Click, 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 click for all of the resistors, and then we're done. Okay, now the thing you want to remember to do is you want to save this on the way out, but I'm noticing in 5.2 here we don't have a save button here, which I think is weird. Why did they do that? I mean, I know, I just saw it right over there, but oh, here we go. Look at this down here. Apply, save schematic, and continue. There we go. Okay, so it used to be right up here in the corner, now it's down here. You hit that, and apparently it's going to apply, save, and nothing. Okay, so you hit that, you hit OK, and then we're back here. Good. Done with that step. So that is, how many steps is this so far? We make the schematic. 1. Annotate everything. 2. Associate. 3. And in between there, we run some design, some electrical rule check to make sure that everything's doing good, but we won't call that necessarily a step per se. We've now done our association, our 3rd step, and now we're ready to do the 4th step, which is move this to the PCB. To move it to the PCB, we have to generate a net list. And a net list is a text document that's going to tell us all the components that we're using, their associations, and what's connected to what. Okay? Some other programs utilize net lists as well. You could do a net list here, and you could maybe import it into, say, a Spice program or something, right? So that's our next thing. And so if you look around here, here's our net list. Looks a little bit different than it used to, but that's fine. Generate the net list. And when this comes up, here's what I've been doing here all the time. Default format. I don't have any plugin. I didn't pay for any other net list generator. I just hit this. Then it brings you to the directory where you're going to store the stuff. You hit save. Call it lab1.net. Seems good. Save. Done. It generated the net list. If you look over here, by the way, we've got a library cache. That popped up a little while ago. And we have a lab01 net. So there's our net list there. Now, if I were to go do the net list again and generate it again, I don't have to pick anything. Here's the same name. Here's that thing right there. Don't have to give it a new name. Hit save. It doesn't ask you if you want to override it. It just does it. Okay? So if I had to come back here and make a change, oh, shoot. I didn't want R1 to be R1. I want it to be R11. Little things like that. Got to regenerate the net list. That might bite you in the ass down the road. If you think that you don't need to do it because it's seemingly such a small change, if you've misunderstood what a net list is doing and you think that maybe it's just the connection of LEDs or all the components together, but it's not necessarily the documentation or something like that, well, that would be incorrect. Anything you have to do, anything you do back here at the schematic, just like you imagine you'd hit save, you generate a new net list. Okay? So now that's done. We can close this. I wouldn't recommend doing this though because you're probably going to be back. It's not a big deal. Nothing's going to break. You just got to open it back up. So we'll be done. Now we come over here to PCB. We open this thing up, and this is almost the big deal. What do we? This is now what, the 4th? Let's see. We generated the net list. We call that 4 steps there. I don't know how many freaking steps we got. So we're here, and now we're going to import the net list. There's nothing to do yet. We could place some footprints and some pads if we wanted to out here and such, but we're not going to. We're going to make a net list? No, we're going to read the net list. So this will read, it will look in the folder that all of this project is in. If it sees a net list, it will read it. And it will do all the stuff it's going to say here. Now, if we were to generate, say we had a mistake, we did some wiring and we wanted to we redid something in the schematic, which caused us to have to generate a new net list. Then we have to come back here. You've got to read the net list again. If you didn't say keep on some of these things, you might end up wiping some stuff out or changing or deleting some tracks. So you read through these and you'll kind of get the idea of, like if you change a footprint entirely, should you keep the extra footprints or should you delete them? Well, I probably want to delete them, so I'm going to check that, right? If you've made a change to the footprint over somewhere, do you want to change it? Yeah, probably. Don't keep the one that we already have. Blah. Okay, so move this over here, and I hit read net list, and it pretty much happens, bang, right off the bat. See that lump of mess right there? That is, there we go, there. That's nice. It gives us a little cursor to move it there, and there is all of our board. Now, they're kind of actually all fairly organized. A lot of times, and I don't know if this is new with 5 or not, but they would just mash them all right over the top of each other. Interesting, actually, because there's some buttons that are kind of missing. So I have to look at that because we had the auto route and the manual button up here, which I'm looking around and I don't see it anywhere. So maybe it's all been incorporated into here. No, that didn't do crap. Control Z, bring everything back. So I'll dwell on that for a little bit. There used to be a button, manual and auto route. Don't use the auto route. We're not going to use the auto route. I might use it if it still exists. I'm sure it's in here somewhere, but yeah. Oh yeah, I knew that. Auto routing quite frequently is a really massive easy button that doesn't quite exactly do what you want it to do. So think about that. And then there was also a way to, with the manual one, you could explode these things out. But it looks like they're already there. So waffle, waffle, waffle. So let me move this around here. So now this is not going to be our board. Our board isn't going to look like this. So we're going to hover over, hit M for, oops. Hit M for move. There we go. That got it. Be careful that you don't grab just the text. If you caught what I was doing there, I was grabbing just the text. I'm going to bring it over here. I'm going to rotate it. About like that. Okay. And then I'll move this one over here. I'll move this over here. I'll move this over here. And we start getting things laid out in what we believe is a good order. Is that a good order? Bing, 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 bing. It won't matter. We can route it just fine, but maybe it's not the way we want it. So I'll move this here and keep everything kind of aligned. Notice your negative mark here, the flat, right? That's kind of nice to have on your footprint. And also notice that in the course of making this thing, I didn't indicate any, positive or negative symbol for where the battery. Oops, see, I got that R2. Hit escape to drop it. I didn't God damn it. There we go. I didn't indicate any positive or negative. You could make your footprint have positive negatives built into it so that you have to do it that way. With these 2 terminal blocks or 3 or the terminal blocks. Or pins. Sometimes I make ones that are just plain pins, so I could just use them for holes or test points or whatever the hell. I maybe don't want to have a bunch that have positive and negative, other ones that are negative positive, and some that are blank. So if I just leave them blank, a lot of times for me it's fairly obvious, which way is going to be which. And then once you get it into, here, let's give us a lot of room here. Once you get it into the board layout, then what you can do is you can come over here for text. You can click here, and then you can just say positive, and I'll probably knock these down to a 1 millimeter. Oh, the thickness. Yeah. Make sure that your board house can actually print these small symbols, the small fonts. By the way, notice what I just did here. another tangent. I added in a symbol, and it's in red. It's in red because it's actually a copper pad right now because I accidentally did this on the front copper. More on this down the road as it goes on. I hit escape to drop the tool, pick this thing, delete that. Easier to delete it. I could just move it. I am going to go here to front silk screen. And so this is just a quick indication of what's going on here on the side. So if I hit F silk screen, that's front, not the back, front silk screen. Now if I come over here and I make a text, hit the plus sign, change it to 1, and I'm going to make the thickness be 0.15. Hit OK. You see? So that indicates, like all the others, that this is a silk screen item. It's going to be drawn, printed on your circuit board. Okay. If you want to put the minus, you can do that too. If I want to do the minus, and maybe I want to make things a little bit easier, maybe I want to do a lot of different text here, hover over here, hit, this is kind of funny, right? I'm hitting C to copy, C to copy, C to, oh hell, that's not working. Control D. Control D? Well, that's weird. Hit E for edit. Yeah, sure enough, that seems to be working. Now I can just make the change to minus, and everything that I just changed previously was there. I don't have to do that again. So, you know, what the hell? Why Control D and before it was C? Who's doing this, right? So it would be nice if they change it. I think this is kind of like all the things in the world that we start doing, like conventional electron flow and yada yada yada, that somebody did it one way and somebody did the other way, realize it, and now they're probably never going to change it. But I get the feeling that maybe different people wrote the two different interfaces. If you hit question mark, shift question mark, well, I'll be damned. Question mark doesn't work any longer. List hotkeys. Control F1. Okay, well that's new too. Look at that. Control F1 lists your hotkeys. Thanks. So if you go through here, here is all of the hotkeys, not for KiCad, for this particular interface right here. So if I want to copy, we got Control C. So I could have done Control C, but it's not just C. But I hit Control D, and that worked just fine. And where is it? There we go. Duplicate. So what's the diff there? I don't know. Probably drags it when you do the duplicate. Anyways, this is how you can find out some of these hotkeys. Don't plan on memorizing all of these. Just know it's there. Whenever you go to do something that it seems like it's a little bit awkward or couldn't there be an easy way, come here and check your hotkeys. So now it's Control F1, or it's probably easier to just go up to help and hit the button. Look at it and see if there's something here that will help you. Right? What's C? Add zone cut. See, I don't think that's more important than copy. They could have done that the other way. Anyways. A lot of talk today about stuff. So we're here, and now we want to route the whole thing. And so then that's our next step. Look up here, though, by the way. We also have a bug checker here, so we can do our design rules check now, I guess, instead of electrical. Let's see. Okay, you can't quite see this. If I hit start, to it, everything actually kind of looks fine, but there's a bunch of stuff over here that's not connected, obviously. So we're going to have to fix that. Okay, that's the next thing. So after doing some research, it looks like KiCad 5.0 has done away with the auto router, which I think is kind of interesting, maybe funny, that I never have used the auto router with KiCad before, up until maybe I'd say even 6 days ago. I mean, I don't even think it was a week ago, right? I was doing some a little lab board of real basic circuits, and I thought, oh, hey, let's go investigate this auto router thing and see how it actually works, because honestly, up until, I don't know, about a year ago, I didn't even think KiCad had one. I knew I saw something up there, but it wasn't, I didn't know how to work it, and everything I have ever been heard or trained to do is don't use auto routers, learn how to do it yourself. And so I burned that into my mind extraordinarily well, apparently, because I just never even considered to do it. And I've made a lot of boards. And so I did some simple labs and went, oh, hey, look at the auto router. And sure enough, even with a simple circuit like this, it basically does okay, but it's kind of not optimal. It's not what you want it to do. So you delete one and you run around. So in that respect, a little tiny bit of me is like, yeah, that could be kind of nice for real simple circuits. But if it's a simple circuit, what the hell is a big deal to route it by hand anyways? I mean, you save yourself, maybe manually routing this thing might take me, 60 seconds, right? The auto router gets done in like 10 and maybe another little bit of a change. So it's kind of interesting. So then, yeah, I think it's kind of funny that I just upgrade to 5.0 and just after I touched the auto router, poof, it's gone now. So anyways, until somebody comes up with a plugin or they decide to create one for it, it does not exist. So yay, you guys get to only understand how to make routes by hand. So I'll show you what that entails. It's amazingly difficult. You come over here and you grab this route track and you go from here and you go to there and you click it. Right? That's some tough stuff right there. Now it does get a lot harder than this. It's really a puzzle. There's one video I put out, I don't know, a year or so ago, going through a really long video. Kind of Louis Rossmann style of just me going through a board that I was making and, bitching and moaning and talking about what I was doing as I was going along. And, you get into these situations where, if I'm going from here to there, no big deal. Here to there, great. It's red, I'm on the front layer. Well, pretty soon, as your board gets more, even just a little bit more complicated, you're going to run into a situation where I need something from here to go up to here, but I just created a line right here and I can't go through it. I can't run a piece of copper over the top of the other copper there, and I can't exactly make a bridge over the top of it. You can make a bridge, I'll tell you that in a second, but you have to go jump through underneath so you can make a tunnel. And so then you can make a via and you can pop down to the bottom layer and you can go underneath of there, and that's cool. But even that, then pretty soon you end up having other walls that you run into, and it is a really big puzzle. It's pretty much a video game on how you'd go through and connect one route to another. So there, route's done. Now, the thing I was going to say about making a bridge, sometimes you'll see this around. You might be looking at a board and you'll find a little surface mount resistor somewhere, or maybe in the older days, just even a regular resistor, or a wire that's 0 ohms. And you're like, why the hell did they put a 0 ohm resistor in here? And I guess you could put it in as almost like a fuse, like some kind of like extra, double extra protection that maybe it's got low wattage and it'll pop or something. That there's other better ways to do that. But typically, if I needed to get across from here to here, I could drop a pad right here. I could drop a pad right here. Basically, I could put the SMD resistor right over the top of this line right here. So one pad's on one side, one's on the other. You wire into that, you wire into that. Your design rule check right here doesn't have a fit because it looks like a component that belongs there is there, and that's what it's supposed to do. And you create yourself a little bridge right over the track. So that's a pretty cool way to do that. So kind of keep that in the back of your head if you're struggling. I hope that I don't see your boards in the future with 1,000 different 0 ohm resistors everywhere because you didn't feel like going through the effort of trying to route well. Now I think the last thing to do is to define the outline of our PCB and kind of call it done, because as I talk and keep talking, I keep finding myself slipping down these rabbit holes of conversation on what you could and should do. For example, should I do a ground floodplain on this? And should I make the size of the traces bigger? And should I move things around? Or any of these things putting off a lot of noise and maybe I should move them somewhere else or to a backside of the board or what have you? I don't want to talk about that right now. I just want to show you how do we get this done and get it to the board house. So after I've done the wiring here, how about we go here and we'll do a DRC. We'll start it. Ding, 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 ding. Everything's okay. Unconnected. Make sure you check both of these. Here's problems. No problems. And nothing unconnected. So we are pretty much good to go. You don't have any definition on what this board is right now. so you can't really send it to them as is. So you need to come over here to your edge cuts, and we're going to draw a line around it. So you go edge cuts, and then you pick some of your graphic tools right here. That's kind of nice. We got a polygon there. We got a little curvy bit here. We got a circle. So let's just do a graphic line. So you go, okay, well, I'm going to start about over here. Go to about over to that dot right there. Bring it down. It snaps to your grid resolution, and I didn't really want to talk about that yet either, but you can see I've got a pretty fine resolution. It doesn't look like it when I'm zoomed out here, but you can change that up above there. Oh dear, yeah, don't do that. So I'll come down here and I'll bring this across. Oh, I screwed up. What the hell? I'll delete that. So much for simple. There should be a little garbage can right here. You can come by, you can click it if delete doesn't work. And I can come back, get right on that point. Click, bring it down, bring it over. And then when you have this little bit dangling here, just hit escape and it'll clip it off. Okay, that's our board. Okay, now we're done, and you could save this. There's definitely more to do, but you could do this. You could send this out as is, sort of, right? Now, if you were to go to, say, Oshpark is a pretty good site. They'll take your KiCad. Last time I was there, it's been a little bit. Sorry, Oshpark, but it's been a little bit since I've been to Oshpark. But you could upload just your straight Eagle PCB or your KiCad PCB. Just straight files straight up into there. Everybody else wants Gerber files, including drill files. And so that's what I want to go off of, because that's going to be kind of the norm for the rest of most of the places in the world. So to do this, you have to export it, and they call it plotting it, right? But before we do that, we might want to take a look at, does this look okay to me? So you go up here, and up at the top, you're going to see 3D Viewer. And this, for a lot of people, is really pretty cool. If I hit this, my board is going to pop up. And I can open up the full screen, and I can roll this around, and my resistors are pretty wacko looking there, actually. So that's odd. But so we got our LEDs, we got this, we can rotate it around. It doesn't quite move as swell as other CAD programs, but it's there, right? So you can take a look at this and see, yep, everything seems to look okay. It is a lot more helpful than maybe you might imagine. You might think it's really cool to show and go, whoa, that's going to be my board, cool, right? But it actually turns out to be pretty handy for things like, am I going to be able to see my values right here? Is if I'm sitting here, if I got a big, bulbous whatchamacallit over the top of this thing, did I just end up covering it because I didn't plan for that with my footprint, right? And then you could put, like on the back, I'll typically put a name or something, done by me, and you could look at positioning for that. So let's give that a try. So we'll add one last little tidbit here, and then we'll export this to Gerber files for upload. As usual, so much for a short video. So I am going to go to front silk screen, and I will come over here and I will give it a click, and I'll say my board, and then I usually do something and say rev 01. I would highly recommend always put a rev number on here, and probably put a date. But because of spacing, a lot of times I'll just go like this, and then I will duplicate it, put another one here, and then I'll edit that, and then I'll say what is it, 12 something or another, right? Whatever, it's December 2018. Give it a date, right? It's there, 22nd, something like that, right? Then maybe I'll make this one a little bit smaller, and 0.11. That's pretty tiny. Oh yeah, that's super tiny. Then I'll move that over So now we've got some information on there. So when I get this thing built, I can see that. Now you can move it off in a corner, get it away to wherever you want. Your object is going to kind of end up being trying to make this board as small as possible because it's a good skill to have because we're always dealing with constraints. And, well, actually, they're probably both exactly the same here because cost, right? You don't want to spend so much money, but you might go, yeah, they're so cheap. I don't really care. I'm going to splay them all over. Well, if you get a job doing this somewhere, they're going to have a cost. Everybody's going to have a cost. They want to save some money. Everyone wants to save some money. So you developing your routing skill set in the smallest confined area as possible is going to be a very strong benefit. So get all these things smashed together. Then you're going to get your little words wherever you want them. Hopefully you got enough room for that. And then ship it. So let's do this again, but let's go to the back silk screen and we'll do another one. So now we go here, we go text, and I want to put this right up at the top. Remember that in the back, well, let me show you here. This goes on the back. And we'll leave it okay. And notice it writes it backwards. And you start going, well, I can't quite fit it here. I can't quite. And you're looking for a place to put it. But realize on the back, look where my cursor is, or the bottom of the words there. See that pad right there that I'm on? The pad 1 right there? That's all I have to dodge because all this other stuff is on the front. So if I put this right about there, I should be in the clear. Okay, and so this is why the 3D viewer is handy. So if I go 3D viewer, I look at this and I roll this around. See what I'm talking about? Nice and easy to read. The only thing that's going to be here is a couple solder joints, and that's it. And if you've got lots of room, write yourself some notes. Okay? You know, if this isn't going to major production, write a whole bunch of crap on here. Write what your thoughts and theories were. Make this be your notes if you need. Right? That's a really nice thing to do. After it even goes to production, maybe on the board, feel free to list all of its benefits and what it does. If you're doing test points will have to be another video. Adding in test points is a great thing to do so that you could see what you're supposed to be getting for signal and power or whatever at different points. And having all your test points around, you could say like we got TP1, TP2, TP3, TP4, right? Maybe on the back here you write TP1 is power in, TP4 is signal X, TP3 is signal Y or whatever, right? And or what you're supposed to be getting there, okay? If you're really slick, you can even import a picture. You could take a picture of some sort, turn it into, it's kind of got to be a monochromic type thing as you could imagine, but I could even see that you have like a little baby version of a sine wave right here that at TP2 you should be seeing a small sine wave of so many hertz. At TP3 it should be rectified and maybe you're seeing part of it and somewhere else it might be, you know, go through an ADC or something like that and you end up with some kind of other square wave. So yeah, you could design all of that into it if you felt like it. Okay. So, last thing. Now we have to turn this into a Gerber, bunch of Gerber files, right? So there's going to be several different ones that are going to all go over the top of each other, and we're going to do that with plot. Kind of wish they would have just called this export, but it's, you know, export's got other things. So here's what it is. You come through here and you say, okay, I want to put it in some output directory. It's going to be a Gerber file. I want front copper, back copper. Do you want copper? Yeah, we want copper. So we want these checked. Do you want front and back adhesive? No. Do you want front paste? Do you want to generate a solder paste file for this? You know, maybe, maybe not. Front silk screen, back silk screen, front mask, back mask. Edge cuts, these are the things we want to have, okay? So, I don't really need these. So I'll get rid of those. And then, I'll just show you this. Then you just hit plot. You got to give it an output directory. So it's going to go into lab 1 with all of our other stuff, right? Hit that. Sure, yeah. And then hit plot. Blip, 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 and it did it. It said all these things were created. Okay. So now if I go over here, in the folder that's got the PCB, it's all kind of a mess right now, right? You know, it started as a .pro and a schematic and a PCB. Now we've got a net list in here. We've got a library backup in there somewhere. But here's all my Gerber, GBR, right? Here's all my Gerber files for each one of those things we checked is a separate layer, you see? And we're going to have to deal with that in a second because the board house doesn't want all these things as separate files. Now we're missing one thing though, so that's kind of the quick and easy output folder generate, right? But we need to also make a drill file. So I'll move this off to the side, and we'll do it again. So it's the same location here. Generate the drill files down here. You hit this, and it's going to open up another window. And you look, and it says, you know, what type of file do you want to use? All the defaults here, inches. Believe it or not, when everything else is in millimeters all the time, the board houses like inches for things. They kind of go off of that for hole sizes a lot of times, most of the time. Pretty much, I can just tell you that everything here is pretty much fine the way that it is. The output directory is our lab 01, and then you have to say generate the drill file. So you hit this, watch down here, created it. Okay, if it didn't do that, then it didn't get done. So try it again or figure out what's wrong. So all it did was generate holes for drills, but the drills are going to be at the defaults, you know, for well, the footprint, the board house, and such. So far yet, everything's been fine, but keep mindful of what you want your hole sizes to be. I'm going to go ahead and close this. So in your footprint here, when we're developing footprints in another video, you want to make sure that you check again the data sheet. So we are going to be living at DigiKey and Mouser and any of those other places like that that have our data sheet, so we can go through that. We're going to see all the electrical properties, characteristics that we need to look at, but we're also going to see all of the 3D documents as well. So you need to know not only just the size of the part, but you need to know the size of the pin. And when you look at something like, say, a MOSFET pin, and you go, oh, hey, that's not very thick. Well, it's wide, right? And you got to accommodate that as well. And you have a thing called tolerance. So in CATIA and Fusion 360 and anything in the shop that we're doing in that side of the fence there, in my other videos you watch, all that stuff we do, you can't put a 10 millimeter pin in a 10 millimeter hole. It does not fit. You need to have a little bit of tolerance, not unless you freeze it or heat something, right, for a massive interference fit. So if your hole is a tenth of an inch, if your pin is a tenth of an inch, then you maybe want to go maybe, you know, 0.11, 0.12 with the hole size. Remember, the solder can accommodate pretty easily for most things, but not too big because you don't want the sole anchorage to be just a big flood of solder flowing through, making a giant mess. All right, I'll bring back this window over here, and somewhere in here, there we go, here is our drill files. Great. Now we're almost ready. Gosh, we're always almost ready. What I want to do is I want to go through here, and this, by the way, it probably would have been better if I would have posted, wrong word, wrong video. I export all of my Gerber files and drill files into another folder first, so it would be easier to do what I'm about to do. It doesn't quite matter, but it would have been easier. So you scroll through here, and here's a Gerber file. I'm going to hold down Control, not Shift, because I want to pick just the ones. I don't want that library file. I want a Gerber file. I want a Gerber. I want a drill file. I don't want my sim table, right? Then I go here and I say compress. Windows users, 7-zip, right? Go find a zip file, right? Not the stupid ass Windows one. Go get 7-zip, something that's free, open source, whatever, and turn it into a zip file. So this is going to be called lab01.zip. Sure, sounds good. Hit create. This is going to be what you are now going to upload. There it is right there. We're going to upload this to a board house. So here is Seed Studios. No love-hate for these guys whatsoever. Not pushing them, not pushing them. Just a place I'm looking at. JL PCB is good. Osh Park. And, you know, a bunch more. A lot of these Chinese board houses, the interface you're going to go look at here is pretty much all the same. So look at this here. If you hadn't seen this before, here's our starting price. It's $4.90. You can get 1 to 6 layers. They're going to be 100 by 100 millimeters or less, but you're going to pay the same for any shape, 100 by 100 or less. And you're going to get 10 of them, 10 for $4.90. Now, they're going to get you with shipping, right? So people say, oh, yeah, see, right? So $20 in shipping. Yeah, see, that's ridiculous. $4.90, $20, that's ridiculous. Well, it's $25. $25 gets you a 6-layer board, potentially 100 by 100 millimeters, 10 of them, with solder mask, different colors if you like, hassle coated, which is a kind of like it's pre-coated copper, so it saves in, it doesn't corrode. Really nice for cheap. And I can tell you they'll probably be here in a couple weeks or so. So you hit here, and this is kind of the interface. A lot of the places are all going to be very similar. You're going to be looking at this, and it's going to say, okay, what do you got to do? We need to add our Gerber files, and you got to pick some stuff out here. Well, really, there's not too many things you can deviate from the norm here and have it still fit in their price range, in their default $4, right? But you can change colors. This will change, cost some money here, etc. So let's go ahead and upload the Gerber files. Here is our lab folder, so we'll go into that, and the only thing it cares about is the zip file. So that's all it sees in there. Remember, we've got all those other things in there, but it just cares about the zip file. So it sees the lab 1001 zip file, and you say open. Now watch this. Uploads your Gerber file. It's there. Accepted. Things look good. You need to tell it the size of it, right? And I didn't even pay attention, so I don't know what the size is. Hopefully we didn't actually go over. But now, and we're not going to buy this. We're not really going to buy this because this is a dumb board. But we look at this and we say, okay, we want green, we want red, we want yellow. You pick the color you like. And then if you want, you should go to Gerber Viewer. And it's really pretty cool because it will show you if everything was right. If it was wrong, it will look stupid, but it'll show you, here's your board. So here's all your Gerber files right here. Here is the footprints that we chose and showing our traces. We can look at just the top, so that's just the top, and the bottom has nothing except for the through holes and our text. So that's looking right. The theme, if you want to change a theme to red to blue, here we'll do the overall. We'll change the theme to, okay, whatever. It's going to be easy, EDA, or Eagle. Okay, so that's fine. And that's it, right? So now you could look at this and see that it looks right. If some piece is not connected or something went haywire, then you didn't do something right. If you're missing a bunch of holes, if the holes aren't there, or if the footprints are there, then somehow you didn't export or plot the Gerbers out right. You see? So that's good. That opened up in a new window, so you can go ahead and you can close that. And then you're back here, and you go, okay, all looks good. Let's do it. You click add to cart, check out, give them some money. You'll have your board in a couple weeks. 10 of them. Okay? I think that is just nonstop amazing. I think that this is why I do this so much, because I think that this process is amazing. It's unbelievable to me that we can get these things for this cheap, and now we can move our work forward. Everybody, anywhere, wherever you live, you got this place around, you got these different places you can send these things to, and we can start developing our own products and get them out there and start selling them to other people in the world and collaborate with others. On a bit of a side note, I look at this a lot in my UAV industry. So if I am looking at a lot of the flight control boards, if I'm looking at a lot of the electronics, the ESCs and such that are coming out all the time. I mean, if you want to get into something, the whole drone stuff, freestyle drones, the autonomous drones and all of that, if you want to get into something that is on the cutting edge and changing almost daily, definitely weekly, that's the thing to get into. And how can this possibly happen? Well, we've got a community of people working together, right? Which is kind of what the whole open source, open, community-based, all that jazz, open hardware is what it's all about. But you've got these people that have skill sets and different things. Their day jobs are probably quite, doing pretty well. And they'll take, some board that somebody developed, and they'll make it a little bit better. They'll get some friends, they'll start a little group, and they'll work on it, and they'll make it a little bit better. And because of places like this, they can send off and have their, wire mess put together into something that is really nice looking and then presentable, and then they can start to sell it. They make some money, and then they get some money to hire more people and make it better and get a better community. And so it works out really, really good. And so there's my soapbox on that. I just think it's amazing. Why I love doing all of this creation all the time. It's all of us, working together. So okay, waffle over. Anyways, that's going to be it for this. I want to make more videos on all the different details of this. This is supposed to be an overview. We'll see what happens when I edit everything out and try to shrink this thing down to something as linear as I can possibly manage to make it. And then we'll take all those side tangents like, design rules and thickness of traces, different types of, conductance of boards and ground planes, making your own footprints. Holy crap, that's probably going to be the next one. It's going to be creating your own footprints and such, right? And then rather than try to make it a tutorial that has any kind of major linearity to it, I think it's just going to be a whole bunch of pods of KiCad information. Like I'm saying, like how do you go about making a footprint? How do you go about making a symbol for the schematic editor? All right, so I am going to end that for real now. I hope you found this helpful. I hope this is good for you. I hope that you give this a try. That is going to be the intent, that if you take this as a design series, training course, then your tuition is this $25 every now and again to make yourself a board. And on top of it, the components that we're going to go to DigiKey and deal with the parametric search to try to get those things so that you could have that as well. But that's cheap. Most of the components are like a penny or so. All right. Thank you, everybody. That's all.